Hello, and thanks for using TickBoom. I came across this question on the Board of Studies forum where a student was indicating that they were struggling to work out the answer. So I thought it looked kind of interesting, so probably worth working through. The question reads, what is the value of sine 2x given that sine x equals root 3 on 2 and x is obtuse? And I think it's that final part, x is obtuse, that makes this question a little bit interesting. Probably the best way to start with this question is just to draw up an axis and kind of reflect what we're seeing on a diagram, because I think it helps with understanding why we end up getting the result we get. I will end up working through it algebraically, but on this whole element of x being obtuse, we know that an obtuse angle is more than 90 degrees and less than 180. So that kind of indicates that our triangle will be drawn in this fashion, where this is 90 degrees and our angle x is this angle here, being obtuse. And if this is the origin, given we're going to the left of the origin, that kind of gives you a hint that the result that we're going to get will be a negative number in a way. So I think that diagram helps. We don't actually have to draw the diagram to get the answer, but just keep it in mind as I work through the trigonometry. The first thing probably worth noting is that if this angle is x, then this angle here is pi minus x. And so now we can start to work through the trigonometry, because we're told that the sine of x, the value of that is equal to root 3 on 2. And what we can do from there is, if that's sine x, we can then work out sine of pi minus x, which is equal to sine pi times cos x minus cos pi times sine x. Now, sine pi we know is 0, and cos pi we know is negative 1. So that then gets us to sine pi minus x being equal to sine x, which is equal to root 3 on 2, since we're told sine x is root 3 on 2. So now we know that sine pi minus x, and if we remember our SOHCAHTOA, sine is the opposite on the hypotenuse. We know that the opposite side length must be root 3 and the hypotenuse must be 2. So if I kind of call these A and C, really what we can do now is work out B, because using Pythagoras we know that c squared equals a squared plus b squared. So 2 squared equals root 3 squared plus b squared. That means b squared would be equal to 4 minus 3, which is 1. So b would be the square root of 1, which is 1. So we know this length here is 1. But also keeping in mind it's kind of negative 1 in terms of its direction. But again, the algebra will get us there. Now what we want to think about is, we can start by looking at what is cos pi minus x, because using SOHCAHTOA we know the cos of this angle would be the adjacent on the hypotenuse, which would be equal to a half. Now we also know that cos pi minus x is equal to cos pi times cos x plus sine pi times sine x. And again, cos pi we know is negative 1, sine pi is 0. So really cos pi minus x is equal to negative cos of x. Therefore, we know that cos x, being this obtuse angle, would be equal to negative a half. And that kind of gives us the ingredients we need to work out sine 2x, which is what the question was about. So sine 2x we know can simplify to 2 sine x cos x, and we can now insert sine x and cos x, so we get 2 times root 3 on 2 times negative a half, and then the 2's can cancel, and we get to our answer of negative root 3 on 2, and that is the answer for sine 2x. So we can see just by working through the trigonometry and being careful about everything, you do get this negative root 3 on 2 answer, which is the negative of sine. But I think having thought about it in this diagrammatical form hopefully helps validate that, and it makes sense that you end up with this negative figure for this obtuse angle because you're going back from the origin. So hopefully that was all clear and it all made sense and you found that helpful. And tick boom.